Okay, I'm going to go ahead and get started. So this week we're going to be talking about Creo Mechanism Dynamics. So first, a little overview of our webinar. I'm going to start with just a little introduction to boundary systems and move on to an introduction about mechanisms in general and why you want to use them. I'm then going to differentiate the two different options you have in Creo when working with mechanisms. There are just two different licensing extension options that you have when you're deciding what you want to do. And I'm going to be showing a demonstration of MDO, which is going to be, I would say, the version with the most functionality. So I'm going to be showing a little demonstration of that. And lastly, I'll open it up to question and answer. So my name is Sevi Beaver. I'm a technical specialist at Boundary Systems. I have 7 years experience with various CAD software and about 2 or almost 3 now, I guess, with Creo. And I come from an engineering background. Boundary Systems is a PTC partner that offers product lifecycle management, data management, CAD design consulting, training, simulation, etc. As I mentioned, we're a training partner with Creo, but also Windchill, MathCAD, and Arbortext. Numerous industry awards, including Platinum Partner. In addition to that, we also offer other software that's not associated with PTC. We work with Keyshot, Moldex 3D, just a couple examples. All right, so moving on to mechanisms. Some designs don't move, but many do. And that adds new design challenges. For example, a chainsaw that didn't move would have a lot less considerations than a actual working chainsaw. Most of the time, engineers, they don't actually define the motion in their assemblies. So they'll just assign, or rather they'll connect their different parts together just with fixed constraints that don't allow for motion. As a result, they're not using the full functionality that Creo has to offer in terms of modeling and simulating what would happen when the actual motion is in effect. So as a result, to get the best functionality, using this functionality is going to be really useful for most scenarios. As I mentioned, there are two different options in Creo. First, there's the Mechanism Design Extension. This offers functionality. Here, I'll pull up the table on the next page. This offers functionality for kinematic analysis. It includes collision detection, so you can click and drag your components, see how they would move, and if they would run into each other. And you can say where would this part be after a certain amount of time with a certain kind of motion, etc. You can do cam profiles, which also will go through certain motions over a certain time, and you can graph that. The mechanism design, or rather the mechanism dynamics option, on the right there, it includes more functionality, including forces, gravity, springs, dampers, friction, and it lets you graph not only position, but velocity and acceleration in relation to all of these forces. As a result, it does offer more functionality, and it's really cool and useful. The example I'm going to show today is with a spring, and I'm going to show the process of setting this up and what kind of results we can generate there. So a little bit more about this mechanism design extension. So essentially, as I mentioned, you can simulate forces and accelerations in systems with moving components. We can see an example here of a lever, many moving components, a couple connections, including a cylinder connection, I believe. And all of that is able to be simulated, including the forces, torques, and velocities, angular accelerations at any given time. We can still perform kinematic analysis, so position, but also velocity and acceleration, as I mentioned. We can see some of those results graphed on the right. We can see time on the x-axis and any other type of measure on the y-axis there. And we can get these things graphed over a certain amount of time that we can set in advance. Using this, we can simulate lots of real-world things like gravity, springs, dampers, belts, gears, and friction. Here we can see just more examples of the different things that we can graph after modeling, this dynamic motion. And all these can be used by engineers to make changes to their model before they get sent out and tested actually in the field. It can allow you to better understand what's happening with the movement of your models in regards to friction. That in that sense, it can help you analyze failures that you're seeing in the field, looking at why they might happen. And it can test your models as far as creating new versions. How much strength do you need in certain parts? How much force is going to be applied to your model by just being used as intended? All these things can be graphed and quantified using this option. Okay. So with that, I'm going to go ahead and demonstrate this in Creo Parametric. So here I'm using Creo Parametric 7.0, but it doesn't really matter what I'm using as long as I have this Mechanism Dynamics option enabled. So this is an assembly here with just, it's a pretty simple one that just includes a couple different sub-assemblies. So there are some connections are already set up. If I click drag components, and I'm just going to click and drag on this window here, we can see that this does already have some motion implemented. So the first thing I'm going to do, we're going to be looking at this this part right here, or rather this subassembly. And this is the linkage for the door, it's called. So right now, these two cylinders are they're connected to each other. If we go into edit definition here, we can see these constraints are user defined. We have one coincident constraint and two distance constraints. This is not a connection set, rather just user-defined constraints. So there's no motion between these two cylinders right now. So what I'm going to do first is I'm going to change that and make this a connection set. So this distance constraint here between these two planes, I'm going to delete that. Let's see. So I'm going to right-click, delete. We can see that that enables motion in this direction. I'm now going to click to change this to a connection, and we can see that it makes it a slider by default, which is what we want. Now, as far as placement, I'm going to select these planes here as references. I'm going to set a minimum and maximum. So minimum 0, maximum of 30. And I'm going to go into dynamic properties and set a coefficient of restitution of 0.1, which I could be wrong, but I believe it's how much kind of how much bounce something has when it runs into something else. So that connection would, when it reached the end, it would kind of like how if you drop a rubber ball, it'll bounce almost just as high. That would be a very, very high coefficient of restitution, I believe. So we're just setting that to have a coefficient and be a little bit more realistic. These are some dynamic properties that we can set using, or then to be used with this extension. So, okay, I have that dynamic property set. I set a minimum and maximum for the motion on this axis. So I'm going to click OK. So now I'm going to go back to drag components, and I'm just going to drag this back and forth. And now we see that we have some motion put into this subassembly, and it's integrated into the rest of the motion that was already set up here. So we can see now that when this moves out, this cylinder will open and close as I drag this in different ways. Okay. So that's kind of something, that's an example of something you can set up and do with the mechanism design extension. So for this next part, we're going to be using the mechanism dynamics extension, which gives us that, that dynamic functionality. So to get here, what I did, I clicked applications and then mechanism. If this is grayed out for you, that means you just don't have the license for this. If you do have the license for this and it's grayed out for you, then you probably just need to reconfigure your software and change the command configuration. If you need help with that, you can reach out to us. But you're going to go to Applications, Mechanism, and that's going to enable this mechanism tab here. So I am actually going to open this subassembly separately. So here we can see this is just that connector piece from our assembly before. If I click drag components again, we can see it it moves in the same way that I set it. I'm actually going to make a snapshot here of the initial location. So all the way extended. So extended by 30 units. Let's see, it called it snapshot 1. That's instead of initial, which I typed, which is weird. I guess that's okay. We'll go with snapshot 1. Okay. So I'm going to go ahead and enable the mechanism extension again. And we can see we now have this mechanism tree below our model tree. You can see that we have various sections for connections, which we already have some implemented, motors, springs, dampers, etc. So for initial conditions, first of all, I'm just going to put that snapshot as our initial condition. And next I'm going to put in a spring. So for a spring, I can hold Control and select these 2 points. A spring will it'll only let you place this along an existing motion axis. So I had to set the connection to exist before I could even make a spring. Your spring has to have a K value, so that's going to be the stiffness coefficient of your material. If it was 0, that means your spring would not put any pull on anything, even when stretched. So it's kind of just like a coefficient that you multiply your distance by to determine the force. And every material will have its own K value. So we're going to use 100 for the spring. And then U is the base length of the spring. So that's the length when just not stretched by default. So I'm going to set that to 60. Next we have options. I'm going to adjust the radius to be 30, or the diameter rather. And I believe that is it. Okay. So now we can see in my mechanism tree, I have a spring. And that's going to be applying a force on our mechanism. So next thing we're going to do is we're going to run an analysis. So this is where we're going to say over a certain amount of time, what happens in this model, or in this subassembly rather. So I'm going to click new, and we'll see I have an analysis definition window. By default, it's going to run for 10 seconds. I'm actually going to change this to just a half of a second, but I'm going to change the frame rate to very high so we can see what's going on in that half second. Next, we have type. So if we run a position or kinematic analysis, these are available with the mechanism design extension rather than the mechanism dynamics extension. But for this example, we're going to be using dynamic. Okay, for initial conditions, I'm going to set that initial condition that I created before. For motors, I'm going to make sure that we don't have any motors or external loads. The only thing we're going to be having right now is the force of that spring. Note that there's no gravity here, so this would not be the most realistic way to do this. But for the purposes of this demonstration, that's what we're going to be doing to show what just a spring would look like. So I click OK. And now we can go ahead and run this. If we go to analyses, we can see the one I just created and click the green flag. So you may have seen that animation, but the 2 different parts were pulled together by the spring over the course of the half second, and we were able to see that. Next, we're going to be implementing a couple measures. So I just clicked measures up in the top mechanism ribbon, and it pulled up this window of measures that allows me to create various things and then plot them in a graph. So first I'm going to create a new measure by clicking this blank document. That'll once again pull up another window. So this one, my first one, I'm going to do net load. And I'm going to click on this spring. Okay. So we can see that creates a measure, measure 1. I'm going to do this again. I'm not going to call it measure 2. This one I'm going to call velocity. And I'm going to make this the velocity of this point right here. Let's edit this measure 1 to be net load of spring. Maybe I can't have spaces. Let's see. That's probably it. Okay. So now if I want to see a graph of these measures, I can just go ahead and control click, select all of these, pull up my graph, which was just this option right here. And we can see a graph generated for those measures over the course of my analysis, which is the results that I selected in the bottom here. So the first one, we have velocity. We can see it starts at 0 and then increases for a while before hitting the ends of the path. And if you remember that coefficient of restitution, put a little bit of a bounce to model how that would actually work. So we can see a little bit of a bouncing there before it finally settles at 0 velocity. And then we have net load on the spring. So essentially at its most stretched, it had a load of 3,500. And the units is millimeter kilogram per second squared. I'm not sure if that's millinewtons or something along those lines, but we can see that it starts at 3,500 based on that initial stretch distance. And goes down to about a little bit less than 500 at the furthest pulled distance that I allowed on that axis. All right. So lastly, if we just go back to this assembly. Let's see. So if we go back to this assembly now, hope I didn't break something. When we click drag components, we can see that once again that motion that I put on that axis is in place and working. So I'm gonna do something similar here. So if I, let's see, I'm gonna create a snapshot. So if I enable my mechanism design extension, it looks like I already did that. I can do this in this top level assembly as well. So I already have my spring created. We can see that even though I created that in the part level, it's going to go ahead and carry over to this assembly. Once again, we have our initial conditions. So if I edit this, and instead set this as current screen, okay. So if we run that same kind of analysis, dynamic, so we have a duration of 0.5, frame rate of 500, pick this initial condition. So now we can go ahead and run this this once again. And we can see over that time it looks like it's pulling it much more slowly in this assembly over that 0.5 seconds. So to see what actually happened there, once again we can open measures. We can apply these same measures to this analysis we just did, graph per time. We can actually see it looks way different when we actually incorporate that same spring into this bigger assembly. So in this case, we have a velocity that starts at 0 and actually keeps increasing the entire time. And we have a net load that starts at a certain amount, slowly goes down, but once again, never hits that kind of plateau, never reaches where the spring is fully compressed when assembled into this more realistic subassembly. All right, so that brings me to the end of my demo. So with that, I'm going to open it up to any questions, and I'll give you all a few minutes to type those out if you have them. So I received a question, is there more than one way to see which modules or application I have installed? So I believe this question is like relating to whether you don't know what assembly or rather mechanism extension you have and see which kind of licenses your Creo has and what you can run. The answer is yes. So besides actually going on PTC's website and seeing your company's licenses and which particular computer they're assigned to, which is kind of a long way, you can go into your Creo files and run a PTC status. So I can show how to do that real quick. So I'm just going into my my C drive here. Program files, PTC. So let's C, then program files, then PTC. And then whichever Creo you have, you're going to want to go into the parametric and then the bin. And here in the bin, we have PTC status right here. We can go ahead and run this. And what it'll do is it'll show all the licenses that this Creo has access to. So if you have, let's see. Looks like I have to keep pressing enter because I have so many. But essentially this lets you see which licenses you have or your computer has available to it. And if you have something here and you're not able to open it in your Creo, it may just be a problem of configuring your Creo to grab that floating license. For example, if you use a license server, and your Creo just on default might not grab that license, even if it's available. So this will let you see all the licenses that are available to you. So that's one way you can do that. The other way would just be talk to whoever manages your Creo, see if you guys have any extra licenses or something like that. And we could check PTC's actual website to see what's available to your company as a whole. So hope that answered your question. No problem. So I'll just give everybody another minute or two if anybody has some last minute questions. And if not, thanks so much. All right, looks like that's all I'm seeing right now for questions. If anybody has anything else, you can feel free to still type it out in questions, and I will be able to download that later and still get back to you. Thanks so much, everyone, for attending this week of Webinar Wednesday. We hope to see you all again, and have a great rest of the week and a great holiday season.